All right, all right. Welcome and hello. This is for Milestone 2 of the GPE project, and this is the first time I'm actually recording a milestone since the upgrade on the computer. I now actually have two monitors, and I've doubled the amount of RAM on my system. All the speed that Hello World can now operate at. To begin with, Milestone 2 required several things. One of them was that all of the Milestone 1 requirements still existed. Um, Milestone 2 also requires a variety of weapons. Show that your player can equip multiple weapons in game. Each weapon should shoot differently. Show inheritance code of weapon classes. Show the polymorphic stuff. Inverse kinematics. Pickups. Pick up weapons by walking over them. Pick up heals by walking over it. Inheritance. Inheritance is required for several of the other ones. UI for the player health. A killable target, and a target that respawns over time. I am not going to apologize for the amount of time that it took me to make this because I'm making something extremely portfolio quality. And I took the amount of time I felt necessary to make it as polished as possible. And incidentally, in the process of making this project, I accidentally hit a number of the milestones that are actually a part of the final project. All better. Since I'm using the high definition rendering pipeline, some of the last some of the last objectives of the other milestone are going to be easier for me to reach due to the fact that I'm using the high definition rendering pipeline, and I got myself very well acquainted with rendering light matrices and emissions during the process. So for starters, I'm just going to go ahead and pop into the game to checklist some of the stuff that is a part of this project. So right here, you can see my ammo counter in the bottom right here. Currently indicates 0. I'll go ahead and pick up this rifle. Now it indicates 689, which is the ammunition for the rifle itself. Pick up this ammo. Oh, now it's 719. And then I'll go ahead and pick up the health crate, which took my HP up from 80 to 92. And then I'll go ahead and kill my target here. And he dies. And currently the respawn timer for the baddie is 5 seconds, and as you can see there, it's spawning off of an empty, and that's the baddie clone container. And it's dead again. Wait a bit longer. And I killed them again. Okay. Now, currently I have a higher rate of fire but much lower damage rifle equipped. As soon as I walk over to this one, you'll see that it gets replaced by a rifle that fires slower but also does more damage. So this one will actually destroy the enemy in 5 shots, whereas the previous one would actually take 10 because it's only doing 1 point of damage. This bad guy that I have right here only has 10 hit points. And there we go. I'll just unload it straight on the bad guy. So as you can see, every time I kill the bad guy will respawn from the empty container after a 5-second delay. And the code to do that's actually pretty simple. And the only thing that the bad guy is currently doing is he's just using the walk animation to walk directly forward. So now, in order to display the inverse kinematics, I'm actually going to go into the scene, and I'm going to directly manipulate the science rifle here to here, which is a little hard to see because I still have the bubbles turned on. Or not. Let's see if I go ahead. Okay. Okay. Let's just start this back over. so that the positions all line up. So as you can see here, when we go into scene and we go over to this, I'll just go ahead and, since this is Science Raffle 1, I'll go ahead and just turn off the position indicators. So you can see the right hand and the left hand. And then when we go into game here, you can see that it's reaching for the right hand kinematic model and left hand kinematic model. And as you can see, it's reaching behind itself when the rifle's there. I need to work on how the rifle is positioning itself, but as you can see when we play the game, we have the rifle pose, which is just part of the baked-in base animation. And then we have the rifle reach when it's actually equipped. And then he's gone. So that's pretty much everything for the actual demonstration. So now let's go ahead and go into the code. Just drag that over from my main monitor. Okay, so the variety of the weapons. So programmatically, you can see the fire delta here, and the lower this number is, the fire it fast. This delta basically represents the amount of time it takes for each shot, or between each shot. So the smaller the number is, the more rapid it fires. So Science Rifle 2 here, as you can see, we have two different damage sets set for it, but the interesting fact is they're actually not set on the rifle. They're set on the bullet themselves, and that the weapon itself inherits the bullet. But the bullet itself actually has a pickup script on it. Surprise, surprise, surprise. And the pickup script actually has maximum survival time on it as well, so even if the spawning script that's a part of the rifle doesn't trigger, the pickup script's decay will actually trigger. So I don't end up with a scene full of bullets that will never die. And here we can see bullet 3, which is the bullet 3 variety, I like this method about having damage separated to the different bullets themselves, because this allows me to have different loadouts for a magazine, if that makes sense. So I could have like 3 regular bullets, and then an armor piercing, then a tracer, and each one of those could do different types of damage, or could have their own particle trails. So, like, especially since we're actually using projectiles instead of raycast to do the shooting for this, if I wanted to have, like, okay, every 4th bullet in the magazine is going to be a tracer, well, what I'd do is then I'd come in here and I would put the individual render on just the tracer. But as you can see here, the trail render is actually on all the bullets individually, but it's on each individual bullet. It's not being added as a component to the bullet at the time the bullet's being spawned. As we'll see later in the code, we're not doing that. We actually have it a part of the prefab game object. So yeah, this is the one that Rifle 2 uses. If we go back here, you can see it's bullet 3. And then Rifle 1 uses bullet variant 2, or bullet 2 variant. And as we can see here, it has the arch point set to 1 instead of 2. Because bullet 3 has it set to 2, bullet 1 has it set to 1. And this is kind of neat because this allows me to use the on collision, which when we play the game, as I'll demonstrate again here, just for the sake of the argument, when I pick up the gun, I pick up more ammo, and I shoot him, you can actually see that when he gets hit by the bullet, he budges. You can also see the splashy impacts. And these are actually different for each of the bullets because I also spawn a impact. an impact when it hits, and that's part of the bullet move script. We'll look into that, but it actually spawns a particle emitter temporarily on every single hit that it does. And as we can see here, there's actually two different types of bullet hit. And we have like the healing crate here. We only have one instance of that showing up in the environment. For sake of argument, I'll go ahead and toss in an ammo crate, if for no other reason than to just demonstrate the existence of said ammo crate. So we'll go ahead and save that, and I'll just quickly show you the difference between the two. This is just variety and inheritance within the scripts themselves. So you see that my current ammo is 719. Well, as soon as I pick this up, it goes up by another 300. And all that really does is, yeah, that's because it's colliding with the box above it, but that's okay. The green box is just a nicety to let me know where it is. But the whole portion there. Now it can't collide with itself. Yeah. So now I won't get that error anymore because it can't collide with itself. Huzzah! But yeah. So here's the ammo pack, the large one, and here's the ammo pack, the small one. The small one gives you 30, the large one gives you 300. And all of them have the bobbin rotate scripts on top of them. Just like this is the health pack, and the health pack gives you 12 health points, in spite of its ridiculous monster uber size. These are actually all from pre-made assets that I bought off the Unity store for real cash monies. So, now, going back to our script. So, the bad guy spawner is really simple. It's extremely straightforward. Comment-wise, it just checks to see if the bad guy exists. Recreates and resets the timer if the bad guy doesn't exist. And the cooldown is up. So this one's really simple. It just checks to see if the cooldown time is currently greater than or equal to the respawn cooldown. And the respawn cooldown is currently set to 5 seconds in the inspector. And all that really does is that cooldown time, if that isn't true and it can't create a baddie, then it just adds to the cooldown time, the current value of the cooldown time plus time.delta, which is the amount of time that has occurred since the last time time.delta fired, basically. And all this does is it just instantiates a new one into the container within the serialized field. And the only reason this part right here is actually serialized is so that I can see it in the inspector. I don't actually set it in the inspector, there's really no point. So I just reset it here, more or less. Because when I destroy it, it'll blank this out and null it, so that it'll see that it's nulled, and then it'll go ahead and reset it. And I really shouldn't have to explain instantiate, but ouch pickup. Ouch pickup is what I use for my bullets. It is really simple. Collision.collider.gameObject.getComponent. Damageable object not equal to null. So whenever a bullet runs into an enemy at this point, I actually have to use a slightly longer one that you'll see in the other pickup scripts in order to get it to run into the player. I am well aware of this. But yeah. So whenever this bullet runs into an enemy, it deals damage. That's not really complex code. Damageable objects here. This is the base damageable object script. It actually inherits from mono. So it has all of our mono behaviors on it. And this is the one that sends all of our send messages and does our event evokes, as you can see up here. So we have reduce health, gain health. Reduce health is used when somebody does an ouch pickup. And it actually also kicks the undamage event. Then we have the gain health event, which is kind of cool. Because you saw it was shown earlier, but I actually spawned a particle event when let's actually set it down here. Spawn healer. It's showing 0 references, but it's being referenced in the inspector as part of the event. So when the event triggers, it'll actually come back and trigger this. And then what this will do is it'll spawn a healing aura object on top of the player for 1.5 seconds, which is that green particle dotty effect that caused my HP to go up 12 points. That's pretty straightforward and simple, and both Not the Face and player inherit from humanoid pawn. But the one the player uses is actually health. Because health inherits from damageable object, and that's what we attach to the player. The other main base class is obviously going to be pickup. And really all that has as its base class is a inherent amount of time that a pickup will exist before it's destroyed. And the only thing it has for awake is destroying the game object when the timer runs out. Not the Face is pretty simple. This is just the health script that's attached to the bad guy. And this is really all it does, is it just checks for collision with a bullet. And then the interesting thing with collision with a bullet is that it will actually play the sound of being hit when the specific Not the Face gets hit. And you can actually change what sound a enemy makes when they get hit through the serialized field, because you see it uses the audio manager play sound at, and then it'll use the we got dinked game object.transform, and then it sets a hard volume here just because I got absolutely sick of hearing it at full blast. This just checks to make sure if there's a bullet.move connected to it. If there isn't, then it just skips this part. But I don't actually need it to do for this. I already did the hit code damage. Okay, to explain this for the other students in class. A normal is where you have a vertex, which is either a quant or a triangle. And when something hits that normal, it produces a vector, which points away from the object, i.e. let's make the analogy of toast. If a quad or a triangle is a slice of toast, then the normal is the side that the butter's on. So when you butter the toast, what a normal would be where the butter is and the direction pointing up from the butter. So if you're laying like the toast flat, you'd have the butter on top of it, then the normal would be the direction which points up from where the butter is spread on top of the toast. that is about as absolutely urbane and simple as I can get it for a definition. So what this does is it actually passes the this bullet dot good hit collision. It actually passes the collision object into good hit on bullet move, which might seem strange to some people, but here it is. Then what this does is it takes the contact point, which is going to be where the bullet hit itself. It's going to get the rotation of that, i.e. which direction is up from the butter on the toast. And what position that the contact point is, that's vector 3. And then it's going to instantiate the hit sprite, which is going to be that sparky, flashy stuff you saw whenever the bad guy was hit. And then it goes ahead and it destroys the game object, i.e. the bullet itself, as soon as this script gets done firing here. And then it destroys the particle effect as well after a quarter of a second. So when I shoot something and it sparks off the armor, that's what this portion of the script is actually doing. So the first portion that we have over here in not the face, that plays the sound when they're hit, and then this portion over here, that's a part of the bullet movement, actually will go ahead and create the spark, which is easier because the hit sprite's actually contained on the bullet itself. So that's why you can see the variance between the two. Okay, I'll just demonstrate it again real quick. Go ahead and clear that. That's just because I'm using old assets that come from a previous edition of Unity, and I just need to go into their scripts and change which particle reference that they're using. Okay, so I have my first rifle here, and as I shoot him, you can see the blue sparks. Now run back up here, and I'll pick up this one, which uses this bullet. And as you can see, it produces orangey sparks when it hits him. Yeah. The other thing you might be noticing is that when I kill the guy, you see like a mist of red around him. That actually is attached to the on die event. And it spawns whenever the person is killed. So we'll go view that in the inspector real quick, because using the event stuff is a lot simpler in life. Although I have to actually go into the prefab for this. So right now I don't actually have anything stacked up in on damage. I can move stuff around in order to do that, but it's not really part of the milestone for right now. But for the on die, we have when it dies, it spawns the death token, which was the death bloom here, as you can see, because it's really quick. It just gives you kind of like that blood misty kind of thing. But if we go back into this guy, so you can see the death bloom there, and then the heal aura, which this one's also capable of, because it's part of the damageable object script. You see the goodbye cruel world function getting called, and that's just part of not the face. And all that does is it destroys the game object it's on, and it destroys the container that holds it. Because if we go back here, this thing is actually the parent of the minion itself. The main reason I set this up is so that I could have multiple minions within a given squad, and then just be managing them all as part of a squad instead of having to deal with them individually, just because it saves processing power. And I only have to pathfind for one, and then do micro flow path lines for the rest, instead of having to path line each and every one of them individually. But yeah, that's pretty straightforward. The only other things I'm going to showcase, because at this point they're considered additional items that I've programmed, is the audio manager, which it's very straightforward. The unique portion about my audio manager is the fact that I'm actually spawning the sounds and even the music as a independent game object. And I'm doing this because in previous projects that I had done before, I would have the problem where in which the same music would be playing on a different stage. So if I spawn them as separate game objects, whenever I load a new scene, they're automatically destroyed. Especially because they don't have this nice fancy little feature here of don't destroy and load. So when I create these various instances of the game object, whenever a new scene loads up, it goes ahead and destroys them. And as you can see here, we have the master volume, the music volume, and the sound effects volume. And what we have here is pretty much the master volume times the music volume, the sound effects volume times the master volume. And what that does is it just makes it simpler for me, because without having to deal with that. So like this. So this one would be the SFX I misspelled something again, didn't I? Oh, that's right. You have to do. No, I didn't want that. Oh, right. Oh, never mind. You have to use the individual. Oh. There we go. You have to use the individual local reference in order to get it to work right, otherwise it doesn't like obeying. Yay, public static level. Or just public static at this point. I actually don't need that to be static. Actually, I don't want either of those to be static. Actually, I do need them static. Interesting. Well, learn something new. Let them static to begin with. There isn't really much else to cover. This is just the text that we were shown in class in order to do the update for the health. And that's just player.health.% times 100f, which just gives a float return, then it rounds it up to an integer so that the integer, it's always displayed in integers. You don't have 9, 2, 3, 7, blah, 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 pi behind whatever number you put up for the health percentage, because it's using math.f. And then it's just projecting 0, comma for the string format. It's very straightforward. Oh, it's extremely straightforward. Then we have weapon class here, which is actually attached to the weapons themselves, but the graphic for those is displayed on the screen all the time. This one is exceptionally straightforward in the fact that you can see up here that it inherits from weapon, which we'll cover later. Or we can cover it now since it's really not a big one. Animation type. It has transform points for the left-hand point, the right-hand point. It has on attack start, on attack stop. Then it has accessible points for the right-hand target and left-hand target. Not that they're actually used, because I use the points. But it uses public virtual void start update. There is literally nothing in the class other than these base enumerables, which is why I said it would not take a very long time to cover. So the real easy part of this weapon is the fact that it uses these to update, and if it doesn't have anything equipped for the digital display text, it doesn't do anything with it. And if it doesn't have anything equipped, it doesn't do anything with it. The is equipped is actually just Boolean, so I'm saving space by not running a null check against the actual weapon class itself, just running a Boolean check against a Boolean variable. Saves time, keeps it running smooth and quick. Try firing is actually called externally. And what this does is that when it's triggered externally, like say from my input manager, it goes ahead and it triggers, or it calls this, and then this will check to see if everything is up to date. And that is actually updated through the main update loop of the weapon itself. The debug.log firing. This is just literally the firing script. It's called right there. It's actually private within this class itself, so the weapon can only be fired from within the weapon class itself. It can be called, and you can try to fire it from the outside of it, which is kind of mandatory, but it only fires from within the weapon class itself. The input controller just calls an attempt to fire it, and yeah, it's kind of a hodgepodge. All this does is it enables and disables the colliders, because I'm using on collision instead of on trigger, just because I can. Because I felt like they should have a physical existence in the world rather than just be some asmorphic phantom that you walk through to pick up. And then this just covers the collider for the player to pick it up. So, like I said before, this is the longer version, which lets the game object pick it up, since all my scripts are attached to a container that actually holds the player, rather than to the player agent itself. It actually has to call the parent of the game object that runs into it, because the collider is attached to the agent itself, not the container. It actually has to call the parent of the agent, which is the container which has all the scripts for the player, in order to equip it. And yeah, that's pretty simple. But the thing that it does then after that is it assigns the weapon container, which is how it orients on the player's body by calling the equip here on the player script, which we'll just go ahead and cover real quick. Oh, right, it's not on the equip here, it's actually on the humanoid pawn, because the humanoid pawn is part of it. So it calls player, but it's calling player's base class, which is humanoid pawn. But since player inherits humanoid pawn, equip here is a part of player. Huzzah, huzzah. So all this does is it returns the weapon container that's on the agent. That's it. That is the entire sum, purpose, and mission of this, is to return the container to orient the gun on the player. That's it. Shocking. And then this one just adds ammo. So when the player runs over an ammo box, small or big, if it's small, it's true. If it's big, it's false. And then we go back to equipped weapon, which is actually weapon class, because here in humanoid pawn, equipped weapon is actually the weapon class. Automated machine. And then when it adds ammo, it's really simple. It's just right here. Public void add ammo. So small, true, add 30, or false, big, add 300. And that's just the going back over here. Going back over here, that's the big one, that's the small one. It's really straightforward. Then the only other thing that I have running on this right now is a game manager. Yes. Game manager doesn't really do much right now. Just has the typical destroy and load script. And the absolute only thing it does right now is that right at the start of the game, it goes ahead and plays music. That is it. So, other than that, that pretty much covers everything that's a part of it. Pawn is pawn. Humanoid pawn inherits from pawn, simply because that's easy. So that's how humanoid pawn has mono behaviors, but as you can see, there really isn't terribly much to pawn. It holds the agent, it holds the footstep sounds, and it holds the weapon class. That's it, though. I didn't even use enemy. Enemy is just a general script. Ouch, not the face was something I specifically wrote for the sake of Milestone 2. Bullet move is very simple. It existed in... Oh no, wait, no. This is the first time. So yeah. Bullet move is really simple. This covers the bullet moving. This covers the bullet hitting things. That's it. The actual damage for the... Well, this isn't for the bullet hitting things. This covers the bullet spawning the particle effect of hitting something. The actual damage is dealt through ouch pickup, because ouch pickup is a lot easier to vary than the bullet movement script itself. That is pretty much all there is to it, though. Bad guy spawner is what I used to spawn it. Showed you guys that earlier. Bob and rotate is almost exactly the same script that I used in one of the previous classes. It just goes ahead and does a typical rotate. So it's supposed to turn 180 degrees every 1 second. So it's affecting that using time.delta time. That is really all that it does. And this is the bob part. There's the switch that tells it to go up or down depending on how it's distanced, and then it just goes ahead and takes care of the stuff. It's just some really simple math. It uses vector3.world and negative vector3.world in order to do the bobs. And the rotation is very straightforward. It just keeps turning in circles, and then it uses quaternion.euler because quaternions use 4-axis rotations, so it has to be converted into a quaternion before it can actually be applied to the transform, because otherwise it can't be applied to the transform because Unity uses quaternions instead of a simple 3-axis. Because if it uses 3-axis, then it could suffer axis lock, which sucks. Because then it gets bound to a single axis and won't be able to move off of it. Other than that, I've covered pretty much every other script in the previous video, and nothing of it has changed. So that will cover it for me. Thank you for your time.